Well, hello, my friends. I'm here once again to sort of submit the amazing puzzle solving technique where I try to display what's going on. Anyway, you know you're in tune to the greatest show on earth, Amazing Puzzle, where a system is put on display where all sequences must obey one particular rule, and that particular rule must be the fourth term. The fourth term subtract the first term over 3 should equal to the third term subtract the second term. And all sequences must obey this particular rule. First, we have got to look for clues in the puzzle. And if we have 3 terms in a ring, obviously that would be a big clue. So as we analyze the puzzle, but first I've got to show you my main objective for the day. My main objective is to get missing number 0 and reject number 7. Missing number 0 and reject number 7. And remember, this is the rubric or the topic where 11D signifies that there are 11 numbers in the diagram. 8V obviously means that there of the 9 numbers here, 8 numbers will be visible that can fit perfectly in the system. 1 number will be missing. We have got to import that number. And of the 9 numbers here, 1 of them will be rejected. But our main objective is to get a missing number and a reject number. So first we look in the puzzle for clues, and if there are any 3 terms in a ring, that would be a big clue, because the only time we can use the system if we have 3 terms in a ring. We notice 1 here, the guide number, 2 here, 3 here, so this system is gonna go in an anti-clockwise direction, starting each segment from here, because guide number states 1. But if we should look at this ring, we would notice that we have 3 terms in this ring. The first term is 4, the second term is 8, and the third term is 12. So obviously that seems to be counting by 4. But if we should use the formula, we would get the missing term there. So if the first term is 4, the second term is 8, the third term is 12, and the fourth term obviously is missing. We would indicate that with an X. Simply look at it, this looks like it's an arithmetic sequence, simply just counting by 4. So obviously our intelligence and our common sense would tell us that the missing term there would be 16. But if you should use the formula, we should get 16. But we can use the individual formula also, which is much shorter. But for now, I'm just going to use this standard formula where it said the fourth term. Say we do not know what the fourth term is, so I would say x minus the first term 4 over 3 should equal to the third term 12. Take away the second term 8. It's going to be x minus 4 over 3. 12 take away 4. 12 take away 8 gonna give us 12 take away 8 is gonna give us 4. And I jot 4 down. Then we have got to get rid of this 3 at the bottom. By getting rid of this 3 at the bottom, we have got to multiply it by 3. If we multiply this side by 3, we have also got to multiply the other side by 3. So those 3 would cancel out, and we would be left with x minus 4 equal 4 times 3, that would be 12. Now, we need to get rid of this minus 4 because we want x to stand alone. So to get rid of this minus 4, we have got to add 4. If we add 4 to this side, we also have to add 4 to the other side. So this side would cancel out to 0. So we would have x remaining on this side. And 12 plus 4 is equal to 16. So that's the way we would do it with the standard formula. But we could do it a shorter way by using the individual formula by saying the third term 12, take away the second term 8, that would give us 4. And 4 multiplied by 3 would give us 12. And 12 plus the first term 4 would give us 16. So any which way we do it, 16 will be our answer. But we didn't have to use the formula because obviously from the get-go we know that it's an arithmetic sequence, and it would be that ring would be counting by 4. So the first total there is 16. Now we see the fourth sector should add up to 15. We have 3 of the 4 terms, so we have got to know what the remaining term there to get 15. So we can say 15 minus 15 plus minus 5 would give us minus 20. Minus 20 plus 16 would give us minus 20 plus 16 would give us minus 4. So how much more do we add to minus 4 to get to 15? We would have to add positive 4 plus 15. So positive 4 plus 15, that would be 19. So obviously 19 would be the missing term there. And I slot 19 down. So if we should add all these 4 terms up, we should get 15. Now, as we get further into the system, we see that the first term here is 1, the second term is 2, the third term is missing, and the fourth term should be 19. Obviously, this is not an arithmetic sequence. This is a quadratic sequence. So obviously, nobody in the world could just easily look at that sequence and tell what the missing term is. So we have got to resort to some formula. So the first term is 1, second term is 2, third term is missing, and the fourth term is 19. We can use the standard formula to get the missing term here. But for now, I'm just going to quickly use the individual formula. I'm going to say the fourth term 19. Take away the first term 1 would give us 18. 18 divided by 3 would give us 6. And 6 plus the second term 2 would give us 8. So obviously, if we have used the standard formula, we should get 8. But the standard formula sometimes take a little longer, so I quickly use the individual formula. So 8 should be our missing term there. And I quickly jot down 8. And I look for 8 in the system and take out 8. This third sector should add up to 6. At the moment, we have 3 of the 4 terms, so we can use a simple equation. 12 plus 8, that will give us 20. 20 take away 4 will give us 16. So how much more do we add to 16 to get down to 6? Obviously, we have got to take away. So we have got to take away 10. And if we should add all these 4 terms up, we should get 6. So obviously, we are going to get rid of minus 10. As we stroll along, our main objective is to get a missing number and a reject number. And remember, you're in tune to the greatest show on earth, where we can display puzzles from ABC level right up to rocket scientist level. If we're going to try to find out the missing term here, obviously it's a quadratic sequence. Not many people, if anybody at all in the world, can look at this and instantly tell us what the missing term is without resorting to the formula. The first term is 3, second term is missing, the fourth term is minus 10, and the fourth term is minus 15. And many people do not like to work with the minuses because they find it very difficult. But if we should do it step by step, it would be a lot easier. We can use the standard formula to get the missing term here. We cannot look at it and say what the missing term is unless we resort to some formula, because this is not an arithmetic sequence. I can say the first term minus 3, take away the fourth term minus 15. So this would be minus 3 plus 15 would no doubt give us positive 12. Positive 12 divided by 3 will give us 4. And 4 plus the third term minus 10. I can say 4 take away 10 would give me minus 6. So obviously minus 6 is going to be our missing term. So obviously it's very difficult to look at it and tell what the missing term is without going through the formula, because this is not an arithmetic sequence, it's a quadratic sequence. But arithmetic sequences and quadratic sequences, they both obey the same rule. So minus 6 should be our missing term there, and I eliminate minus 6. Now we have reached a juncture where we have got to use a little trial and error, because there is no more clues. And remember, mathematics is about formulas, rules, laws, trial and error, and of course a little common sense. And we have 4 more numbers here remaining: minus 3, 7, 1, and minus 2. But remember, one of these numbers will be rejected. So we have got to use 3 of these numbers to fit in the puzzle. And we have got to import a number, which will be the missing number. So we have got to put our trial and error skills to the test. So first we can say we have two sequences left. If we have any arithmetic sequence, it would be easy. Rather than having a quadratic sequence, we see the fourth term here is minus 5, minus 4. We see minus 3 and minus 2. So obviously we could have an arithmetic sequence in the making. So we have got to trust our luck and put minus 3 here and minus 2 there. But since we have used trial and error, we have got to, I'm going to put a little dot beneath to remind me that these are trial and error. And I'm going to put a semicircle around these two. So in case I am on the wrong path, I can know what to erase. But let us check it and see if we should check this sector up. We have 8 plus 2, positive 8 plus positive 2 will give us positive 10. Minus 6 plus minus 3 will give us minus 9. So positive 10 take away 9 would give us 1. We have a 1 here, so we could be on the right track. I'm going to put 1 there. I'm still going to put a semicircle, put a dot to make sure that if I'm still not on the right track, I will know what to erase. We can add these 4 terms up. We can say 4 plus 1, that's positive 4 plus positive 1, that would be 5. Minus 3 plus minus 2, minus 3 plus minus 2 would be minus 5. So if we add positive 5 and take away 5, that would give us 0. We do not have a 0 in the chart, but obviously remember we have one missing number, and the path that we have taken, we could be on the right track. So I'm going to just put in 0 there. If I put 0 there, 0 is going to be our missing number. Although the puzzle is finished, so obviously we made some good decisions. We didn't use 7. So 7 is going to be our reject number. So there you have it, folks. As easy as much as that. The greatest show on earth. Since we are now clear that we have made some right decision in the trial and error section, we can say we can go full circles. So obviously the missing number 0 and the reject number 7, we have achieved our goal for today. So this is the greatest show on earth, where we can go from ABC level straight up to rocket scientist level. So there you have it. So thank you for joining. Take care.